Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I am joined by my beautiful, wonderful, amazing, and terrific co-host.
Ben Wilson.
Do you do anything, or is your name just Ben Wilson?
Oh, we're doing that again this week. I always forget. Just kidding. I review design integrations at Databricks.
Great. Today, we have a panelist episode. Per usual, Ben and I have been talking for the last hour and 7 minutes, and we sort of settled on this topic a while back, but honed the topic throughout the last hour. And hopefully this will be really valuable to the listeners yourselves, because it helps you sort of inform how you go about learning, how you go about associating yourselves with different types of people in the organization, and then how you also interact with people sort of quote unquote below you in the organizational hierarchy. So Ben said that one of the core Databricks hiring tenets is looking for people who are exposed to greatness. So worked with very top engineers or just really smart people in general. And the rationale for this is what, Ben?
So the foundation aspect of, like, this goes back to looking at somebody's resume, right? Let's say we work for we're looking at somebody's resume who's coming from a household name company in the tech space. Like, hey, I work for, this super famous company. I've worked there for the last year. And at face value, when you're looking at somebody that claims like you look at their LinkedIn profile and you're like, oh, I work at this big name company, and people who don't work there or who have never worked for a company like that look at that and they're like, oh, this person's legit. Like they're an elite programmer or elite data scientist. And we don't care about that. It's the temporal effect of where were you at that company at what time. So what projects were you working on? What company was that? And what stage of their evolution were you there for?
Yeah,
And
so we were talking about Google as an example, and I remember hearing an anecdote from someone who works at Google that the first Google search implementation was linked lists. That like the founders actually built it with linked lists, and then from there, it got a lot more advanced. So if you joined Google, just a little bit, yeah, just a tad. Anyway, if you joined at the very beginning of the organization, you would have been building Google search with linked lists. If you joined at the very end, or whatever now is, you'd be like working on a very, very tiny component of a very complex search stack. Ben, in your opinion, what is the optimal area that you should be, or optimal time frame that you should have worked at Google to maximize your exposure to greatness?
So it's a really tough question and a really tough answer to provide. It depends on what you're looking to do, right? So I've had many people reach out to me over the years about like, oh, how can I get a job at Databricks? Or I want to do this thing at this other company that's really, reputable. And I'll usually answer their question with another question. I'll ask, like, what are you looking to do? And sometimes the response is, well, I'd like to, work for, we're not making this podcast about Google. I've never worked there. I don't know too much about it. I work with a bunch of people who have worked there at all the different stages of that company's evolution. But if we're looking to get in, let's keep on using that as an example. But if somebody's like, oh, I want to go, get a job at Google because I want to build, search. I'm like, sorry, that ship has sailed. They're iteratively improving it all the time, but you're not building it from scratch. It's never going to happen because it already exists. And it's probably a truly monumentally complex, like not just single code base. Like there's a lot of services involved in that. Most of them around making money on ad revenue. But if somebody says something like that, and that's my response, well, I'll say, like, what are you trying to do? Are you trying to learn the process of how something like that is built from the ground up when a new idea comes out, or a dramatic improvement on pre-existing technology? Then you'd need a time machine to get back and, like, try to get hired in that core team, back in their first 6 months of working there, and like, go through the pain and the learnings over time of figuring this thing out. And if you were to do that, you would be imminently hireable anywhere. Like, anybody would hire one of those people, because they had to go through figuring out how to invent new technology and make it work. And by the way, it made that company an astronomical amount of money.
Really? I didn't know that.
So, to the point where they could afford to hire loads more people and build all sorts of new cool products, and then become a commodity and a household name. So the answers that I get are pretty varied from people, which is always interesting to me. Some people will come back and say, "Well, I'm looking to, get that street cred." It's like, cool, go work for a startup. Play the lottery, find a startup that aligns to your desires, and get ready to learn. Like, and get ready to get stressed out and have to figure stuff out and worry about profitability and, like, how do we get more users, and how do we build features quickly enough that people actually care about. It's a very unique experience, being in that high pressure environment, and it could also just go out of business, right? There's lots of factors that go into that, so you have to be willing to take on a whole lot of risk to get into that. And then some people come back and they're just like, I want the name. Like, I want to be able to put that on my resume. And they think that companies are kind of dumb, I guess. Um, like, oh, if I go work at Meta right now,
I
or
think a
go work
lot
at
are.
it depends on where you want to go. So if you're going to a FANG company right now, and you put in, 2 years working at one of these companies, and then want to go work at a startup that's founded by people who came from a company like that, who are looking for a core team to build the product, they're not going to hire you. Like, they don't care, like, where you worked. They care about when you worked, where you worked,
Hmm.
because they're looking for that skill set. Those scrappy, you know, entrepreneurial minded developers who are willing to build new stuff with no context and just get it out there and get it working and then refine it over years of work. Um, so that's that foundation thing. We're talking about the hiring process. It depends on where the company is right now in their own evolution, where they want to be in 2 years, 5 years, 10 years, and what their DNA is at their organization. So if it's an R&D focused org that is constantly looking to build whatever people want, and be on the cutting edge for as long as they possibly can be and continue to do that, the desire for hiring is, you need a good mix of people who have done that before to be able to be like the leads and guide the next generation of people who are building stuff and learning, how to do that. And then you need people who are like recent college grads, who have that sort of like the technical capabilities, the training, they have the knowledge, and they're hungry to learn and break stuff with guidance and fix it. But what
Okay.
they're not looking for is somebody who spent, you know, 2 to 3 years at a bunch of established tech companies, that that person is basically just in, like, maintaining stuff, and then hire them for a role where they're gonna have to be building stuff from scratch. They were never exposed to that greatness, and that's that
Got it.
foundation thing.
So we're sort of talking about the top, like the 99th percentile, the very top. Um, And I feel like if you have Google on your resume, that'll land you like an interview at probably 90% of organizations, um, with a
Sure.
lot of caveats. But you're talking about sort of getting to that like 1% of developers, that 1% of startups, the really tippy top. Is that right?
That's where everybody wants to go. Like, I mean, based on people that have reached
You'd
out
be
to me.
surprised, actually. But yes.
I mean, yeah, there are people that they've learned some skills earlier in their career. They want to just do a 9 to 5 job,
Hmm.
and it's not a passion for them. They don't get excited about building new things. Some people get terrified of having to build new things. They'd rather hire a consultant to do it for them, or they just don't care. Like, hey, I have my quarterly goals, which is to maintain uptime and limit the number of trouble tickets that come in, and make it so that any bugs that come up, we have a patch for them. There's tons of maintenance engineers out there. They
Right.
have a job title of software engineer, but that's what they do, and that's what they like to do. I'm not knocking that. Like, it's a needed thing in any tech company. You can do an entire career of doing that. Uh, it sounds like pure torture to me, but I'm more of I like to build stuff, and I like to be around people that are building stuff.
Right. Yeah, there's just different ways of living life. Like I know, at least in American culture, it's pretty common at like high performing tech companies. But I spent a good amount of time in a few South American countries, and it's like it seems like just a very different set of priorities. It's more about family, friends, having fun, for at least the people that I was around. And yeah, so not knocking anybody who likes the 9 to 5, getting a big paycheck, and then going and living life. But we're sort of more talk, or maybe, yeah. What's that face?
You're not going to get a truly big paycheck being like
Fair,
keeping stuff in maintenance
but
mode.
like good enough.
Your mileage may vary. Like, it depends
Fair.
on if you're working for some small company who's been around for 30 years and you're on a team of 4 software engineers that are just maintaining things, that company's probably maybe paying you 150K a year total comp to just keep the lights on. That's what you're doing. Maybe
Hmm.
you get a new feature or like some small minor tweaks to the product in a year, but it's not like you're focused on reinventing things or fundamentally building new product for that company. There might
Right.
not even be an opportunity to do that. Like, the business model for the company might be like, hey, we we sell education software. Like, that's what we do. And we have this full suite of things that all of our customers like and rely on. There's no other products that anybody's asking for. So nobody cares. They're just happy with what it is. You're now in maintenance mode, and that's what you're doing.
Right. Yeah. Okay. So that like just some caveats that there's different ways to approach professional development, and if you want to be in that top percent, being around greatness is definitely helpful, but it's not a requirement if you want to just hang out with friends a lot. Anyway, that's sort of an aside. Um, so we've been talking about this concept of greatness, and let's say we're using Google as a case study in its whatever 20-year history. If you entered at year 2 and then stayed till year 14, that would be a pretty damn impressive duration to, or like time to spend at Google, because you get to see how it was pre-success and then helped it build success into being one of the most like impressive companies of all time. What types of greatness would you expect to be exposed to in that time frame?
Yeah, and a lot of people have asked me this about Databricks, actually, thinking that it's just code, right? Like, oh, you've seen amazing implementations. Yeah, uh, there is that. There are some very, very smart people that I work with who are very good at implementing features, shockingly so, very fast too. But just because you code good does not guarantee you a role in what you might want to be doing. There's a lot to developing product in a software company that has nothing to do with the code you're writing. In fact, most of the work that goes into building things has nothing to do with writing code. It does tangentially have to do with it. You're talking about how you're going to potentially build something, but most of it's deciding not just what should we build, but what should we not build? What are the
Mhm.
things that are irrelevant? Because if there's no guardrails, you can go and just build all the features. Like, hey, I think this would be a good idea, or somebody's going to need this API someday. And if you allow a bunch of people to do that in a fast moving tech company, all you're doing is creating an unmaintainable mess of spaghetti that's just going to eventually break. It's really easy when you're talking about like building something from scratch the first time and you're like, I'm going to put all the features in it and it's going to do all these cool things. And if you're not thinking about what does this look 5 years from now when I need to maintain this and add in 200 extra features to this over time, or I need to change how this behavior works completely because it doesn't scale, or there's there's some fundamental shift in what the priority is of this product. You're now left with, hey, those 200 APIs that we created, uh, we collected data and only 15 of them are ever really used. The other ones, like, yeah, people use them, but they feel like dev APIs that were made public, but we have to maintain them. And in order to make this change, we have to update all of them and all of the logical, you know, intersections that they all have with the back end. And it becomes very expensive to make changes at some point if you don't restrict what it is that you're doing. And knowing what to build and how to design and build that in a community with your fellow engineers that are all going to have to be maintaining it, being on call, uh, making feature changes over time. If you're not in that environment where somebody is controlling that and seeing greatness in product, about what are our decisions about how to build, get feedback, fix, improve, and iterative development like that. If you've never been involved in that, even if you weren't the primary person doing that, just being in the room and being one of the people that are filing feature PRs and getting review from the person who's got the large context around that. If you've never been in that room, it's hard to be, it's hard to sell yourself for a company that's in the process of doing that. Because they'll ask you questions that, like, in the interview process, you'll be asked questions about, like, hey, like, tell me about this feature that you worked on. What was your role in it? What did you do? What did you decide to build and what not to build? And if you can't answer that question about like what not to build, now that interviewer has some questions. Like, does this person have an understanding of this? Like, do they know what that process is like? Have they ever had to maintain something, or did they just build something that they worked somewhere for a year, built a feature, and then pop smoke and move to another tech company? Like, we don't hire those people because they've never had to maintain what they built.
So you've been calling greatness, or like alluding to greatness being the ability to determine what should and should not be built. What is greatness, though?
Something that is successful in not just in the business sense, but in the ability to retain talent. So
All
you
right.
can build the coolest thing ever, right? You can go wild and build like this awesome new product that in the process of building it, everybody's super pumped and they're like, yeah, this is going to make us tons of money and we're going to get famous off this and it's going to be awesome. And then 2, 3 years down the line, without having a good product direction, it becomes so unmaintainable. And people from the business side are saying, we need more. Like, our customers are asking for these things. We don't have evidence, but this is what they're saying. And you just end up just gluing more and more garbage onto the code base to the point where when you go on call, it becomes like a waking nightmare because you're getting pinged every 30 minutes for Sev 0 incidents. Services are going down. Like nothing works correctly. You're having to do patch fix after patch fix after patch fix. And all of your development time is spent just fixing the mess that people have created. Good people leave from companies like that. So like, hey, like this is so broken and management doesn't want us to fix it. They're telling us, no, you can't like refactor this or get rid of all of these stupid features that nobody cares about. They just want us to perpetuate this monster that's been created. If you get no traction, good people just leave. So greatness is building something that people love to build, is making money, and people love to maintain, or at least the maintenance isn't painful.
Okay. think I'm following. 50 questions are popping up though. The first one of which is, how is greatness disseminated throughout an organization? Does someone walk up to someone else and say, "Hello, this is greatness, goodbye"? Or is it implicit in how you go about your work? Is it a combination? Is it mentorship? What does it look like?
No one's ever going to tell anybody else how to build something great because anybody who knows how that stuff works knows what to say because you never know. You're always questioning that. Like, are we building the right thing? And there's processes around that to evaluate and to shift directions if it's not working out.
So it's like one step above what to build. It's the process about deciding what to build. That's greatness.
It's having voices involved in that conversation and a an agreed upon way of doing things. So you have processes in place, you have people that are driving those processes, you have accountability to adhere to those processes, and everyone is sharing this sort of hive mind approach. Like, this is how we do business, this is how we're building. And you absorb that by doing that, not just by looking at it or studying
Mhm.
it in a book. You have to be there. You have to feel the pain. You have to be that person who created the incident that broke something and then you went and fixed it and learned from that. Or you built something thinking it was going to be used in this one way and you find out later on, whoops, I didn't account for that. Uh, we're not we're not preventing our users from using this way. And all of a sudden problems happen. You learn from that retroactively. You discuss that, analyze that, and then you fix that. So that the next time you build something like that, you remember that pain intimately. And that's the wisdom that comes along with it. So learning greatness is suffering through your own personal idiocy or a group idiocy or group ignorance and learning from it. And eventually, the organization and all the members of it are attracting other people from outside experiences who have done things and learned from them. And they've also experienced greatness.
Do you need someone in the room to have experienced that idiocy, or can you just know how to do stuff correctly?
I mean, it depends on what you're trying to do. So some problems are kind of academic. You know the foundation for what it is that you're trying to do, and you know your requirements. So you can academically test something. You know what to test because you can think through what could go wrong. And a lot of things are that, right? We do acceptance testing. We do, bug bashing. We try to break what we just built, and inevitably we do, right? You break it and fix it. And there's some times where something's so new, you just don't know. Should you instantly start building a product out of something that you don't understand? Probably not. Go and try it out first. Build a prototype, break the prototype, have other people play around with it, test it, and have other people's ideas be included in it. somebody has a great idea of how to fix this issue where we're not directionally aligned to the product vision. Don't tell them to shut up and stop talking. Listen to them and hear their feedback. And whether that be a customer that's using your product, or an end user who's struggling with what you built, or another engineer in a different department, or a different team who's bringing this stuff up, the greatness aspect of that, of development and listening to thoughts that people have, is being open and like respecting people's thoughts and opinions, and listening to them.
Yeah. Let's take turns giving some examples of a story in our life that informed us learning about how greatness should be defined. And I'll kick it off really quickly with a prior uh, project in a prior company. Basically, I was building a A/B testing pipeline that was bespoke and sort of outside of our main A/B testing stack, and it was used for a few special cases. And I remember it was my baby. Like I tried 7 different things. I wrote it in Spark, Pandas, Modin, which is like a parallelized version of Pandas. I did what's that library that allows you Numba, which
Mm.
basically allows you to write C-esque Python applications, and Redshift SQL, which is the worst thing on planet Earth. And I remember I built it, it finally was working, and then one day it was like someone was reviewing the dashboard and they said, "Why do we have 200% revenue lift on this experiment? Like, is it actually that good?" And turns out it was a bug, and I had to fix it. And there was like a little bit of embarrassment saying, "Oh, a product manager saw this, got excited, told someone, and then it actually was just a bug." And that really taught me the importance of keeping things simple, because if I in that case it was not over engineered, but there have been so many times where I over engineer solutions, and then A, it's more error prone, and B, it's so much harder to fix errors when they come up. And now that like implementations are just a solution to me, about a year ago they weren't. It was like, oh, cool to like over engineer stuff. Now if a one liner does it versus a 10 liner, I will always go with the one liner. And the sooner you can learn that, the better your code will be.
Yeah, and the way you learn that can is one of two ways. When we're talking about like the process of directionally moving towards greatness, um, one way is the hard way, which what you just explained. Like you built an abomination, and now you gotta sleep in the bed that you made, and fix it, and it's probably super painful. Um, the fast track way of learning that is to have peer review, where somebody who looks at the implementation and just asks you that question, like, why not one API? Like, do we need all of these, like the same implementation in 7 different languages or 7 different implementations? Because if something goes wrong, you got to fix this everywhere. Um, and how do you test all of that in an economical fashion?
I don't think it hits as hard unless you've actually gone through the pain of like reworking a crappy over engineered solution. Like, yes, someone can say you should probably do it this way, and you logically see that. But now I have like a visceral hate for over engineered things. Like it like is jarring to look at. And that's super powerful.
Yeah, it definitely, and you'll never forget that. Um,
Right.
but there's also a way to do that in a team environment where like a tech lead can get you to realize the same thing by just a single sentence, or like to ask you to make a change that might not be super relevant, but just like, hey, could you just show me what it would look like to change this one thing? Or like, hey, what if we add this feature? How are you going to add it? How long is it going to take? And show me the tests. And if you get that request on a review and you're like, you'll have that realization before it gets to the point where people are using it and finding like crippling bugs in it. Sometimes that question can open your mind and you'll remember it when you have a mentor that's like, not trying to be a jerk here, but can you like, do you think that what you built is maintainable? And sometimes that just opens your mind up into realizing maybe there was a simpler way to do this. Like,
Yeah.
am I doing something dumb here? And you kind of have that realization like, oops,
Yeah.
time to rethink what I'm doing.
Yeah. And just to wrap that thought, greatness isn't making simple code, but it sort of is. Like if you can, I would argue that sort of greatness is asymptotically finding the simplest solution that is a solution, because simple is easy to maintain, it's typically cheap, and it's easy to build. And so I, th- I mean, that might be going out on a limb, but would you call like the simplest solution to a problem greatness, Ben?
I'd say that the thing that solves a problem in the most maintainable way for me personally is what I go for.
That's perfection, quote unquote.
Well, nothing's perfect. And
Yeah.
nothing in software is perfect. Um, but the weird thing about software development that I've learned over the years is that it's way easier to make shit code, like way easier than it is to make simple code. And that might sound stupid, but the amount of thought that is required to go into a well-crafted API that meets all of the requirements for extensibility and most importantly, ease of use and making it, if you can create an API interface that people never have to look at the docs because it's just intuitive, it just makes sense. There's tons of examples in pick a language, look at the core library APIs. And when you're trying to do something like, man, how do I cast this from a string to an integer? And you look and you're like, oh, there's like a dot to int or a as int open parentheses, close parentheses. You're like, that just intuitively makes sense.
Mhm.
And if you do have to look at the docs, it's very easy to find. You understand the things that it does, but most importantly, the things that it doesn't do. And you realize, man, the core language developers are really good at what they did. But if
Yeah.
you look at when they implemented that, it had dozens of comments and arguments about like, should we do this? Should we do this other thing? Or what about this edge case? And you look at how consensus was arrived at and the simplicity that was generated from that. And you're like, that's really clever. But it took a lot of work to get to that. And then if you're really interested in how to properly craft like that sort of API, but make it as simple as possible for something that is actually complex underneath the covers. And you go look at that implementation and you see the same sort of pattern that was done there. Like the first implementation was really complicated. And then people were challenging it, saying, well, couldn't we simplify this or reduce the scope of this and make it so that we can test this in all the ways we need to test it and ensure quality here and ensure reproducibility and things are going to work the way expected. It takes a lot of effort to do that. And it's really complicated to remove complexity from code. So that's when you get exposed to greatness, when you see people doing stuff like that and are involved in that conversation about the sheer volume of thought and emotive expression sometimes that goes into analyzing that and making it better. You're now being exposed to that greatness. You're absorbing that perspective and that point of view of other people and saying, there's a reason they're asking for this. And what is that reason? And I'm going to go analyze why they're saying this. And then you start thinking about that. And when the next thing you build, you have that in your mind. Like, I need to keep this concise and short and clean.
Do you have an example for when you were exposed to greatness?
I mean,
Ideally, a fun and saucy one.
it's pretty much like my entire working time in engineering at Databricks is that, you know, every day you get to see that. every PR that gets filed from your peers where they're working on a new feature, that's not to say that everything that people produce is perfect, but you're seeing directionally people making decisions that make sense for what we're trying to do, and thinking through and debating and coming to that consensus where, or like, we're building the thing that needs to get built in the way that makes it testable, maintainable, extensible, and highly collaborative. So that's when you see great things being built. And it's like every day is like that. Um, Even if it's a day spent reviewing people's designs for the things they're going to work on next quarter, and helping out, like answering people's questions, that collaborative nature is greatness to me. I have many examples over the years of not greatness at places that I've worked.
Yeah, like what?
Somebody like trying to kick off a new project, and they effectively go into Gollum mode, where with their project and their code, everything's in their head of the design that they want to do. They go off and build this abomination, and then just try to push it to prod. Or if there's like zero guardrails at the company, nobody's involved, there's no adult in the room ever, they're allowed to just deploy this thing and have it be like customer facing. And then the rest of the team's like, what is going, like, why is this so broken? Like, it's supposed to work this way, and like it's just filled with bugs. Or why do we have to spin up this VM that's, you know 200 times bigger than any other VM that we're using? What's going on here? And you find out, like, oh, it's full of memory leaks, and there's like all the, like, garbage collection isn't working properly here. And you're like, who built this? And you're like, you look back and you see it's like, oh, there's this one guy, or this one lady who built this, and they just pushed to master. Like, there was no review at all. I've also worked places where there is no concept of main branch because there's no repository. Like, this code that is running somewhere uh, is pushed to some FTP server and is pulled every hour to be executed as a script. And you look at the script that's being run, and you're like, this code is like really bad. There's no comments, there's no syntax consistency here. We have, you know, functions defined in here. They're thousands of lines long and are doing hundreds of different things. There's no way to debug what's going on here. And then you look and you're like, okay, I see you have a logger. That's cool. And then there's just a bunch of if statements in here. Like, if logger mode is debug, print this statement. Like, this is your debugging mode? Like, what a nightmare. And I've had to maintain stuff like that and rewrite that from scratch, because I'm just like, I'm not, if I'm on the hook for maintaining this when I'm on call, yeah, I'm not playing this game.
One of my favorite movies is Ex Machina, and without spoiling it, there's a super genius that goes into it's like a very, actually, a lot of parallels to Google, that like this guy founded the Google of this fictitious world, and then he goes into this really really nice place, in like house in a like Alaska looking type of environment, and basically huddles down and tries to build artificial intelligence. He
Like,
doesn't.
general intelligence.
Yeah, yeah,
Yeah.
AGI. And he like gets drunk by himself. He creates an AI to like dance with and do some other things with. He like has his own green juicer. He has like all of his food delivered and basically doesn't talk to anyone. And there's this stereotype of this dude in a basement just typing away, building artificial intelligence, and then suddenly it's there. But what I've been learning is that innovation is highly collaborative, and there's very rarely this genius that goes off and builds something. There are a lot of those stories, but they're sort of touted as the standard when they're typically not.
No.
So Ben, I'm curious, why do you think that is? Because I've seen it time and time again where it's like there's one dude or one girl that went and built this thing and they're solely responsible for it.
because we as a species have an affinity to believe in the divine, right? It's very easy to convince humans of divine beings, even if they are human. And if somebody exhibits the properties of something that is superhuman in capabilities, that's a story that we like to hear. We think like, maybe I could be like that one day. Back here in reality, um, we're talking about implementation of a sufficiently complex system. Uh, my question to you, you're now, you've got some PRs under your belt in ML Flow, and you've seen enough of the source code and see how it works. Superficially at its surface, when you're interacting with APIs, you're like, this isn't that complicated. Like I can log a run, I can
Yes.
log params and metrics. And now that you've seen the internals of how some of this stuff works, I don't know. I haven't given you anything to work on it in the back end, like server stuff. But
No.
when you're looking at that aspect of the project, do you think one person could build all that? Like the state that it is right now, do you think one person could just sit down for like 6 months and build all that?
I mean, like the obvious answer is no, but well, they definitely couldn't do it in a vacuum because it's clear that a lot of the design decisions and product build decisions were informed by customer demands and open source demand. So definitely not without the demand. And then could someone like settle on this architecture? Probably. I mean, you were trying to get me to say no, right?
I don't know. I just want to know, like, get your take on it.
It definitely wouldn't happen. Could it happen? Maybe.
So if it were one person doing it and knowing that what you just said, the direction of feature implementation and like the state that it's in now with however many freaking millions of downloads a week it has now. If you did that in open source, right? You just pushed it to open source, you got a whole bunch of people interested in the project, and they started filing issues for like feature requests. Do you think one person could handle all that?
No, definitely not.
Yeah, because like what would happen in that situation where it's one person interfacing effectively with tens of thousands of users who have all these ideas? You would have to be the gatekeeper, and it probably make a lot of people annoyed. Um, but if you didn't want to make anybody annoyed, you would build all the features, right?
Yeah.
And then if that was the case, the product would definitely not feel like it does right now. If every request came in, we just built. We don't do that, right? Could we? Maybe. Um,
Mm.
it wouldn't work anymore. It would
Yeah.
be fundamentally broken, um, or it would be unmaintainable, right? If you built everything that everybody ever asked for, you
Right.
would be left with this state of a code base where you're like, I can't even test this. Like all of these integrations and all of these features, it's so complex that it's now too difficult to modify anything.
Right.
Even in like developer APIs, it can't do anything. So the collaborative effort and a group of people working on something is always going to succeed. And you look at some of the advanced Gen AI stuff that's being worked on now, that the team here at Databricks, the X Mosaic team, that's not like one genius working on their own, just building stuff. That's a team of geniuses all working together, collaborating with different teams, with different people, getting feedback, going into previews, testing things out, having people like bug bash it. It takes a huge village to make something like that successful, and a lot of very, very smart, very, very humble people that are willing to listen to all that feedback and then filter out what is the most critical thing to work on at what time.
Yeah. And just like providing a proof to the theorem if you think about the distribution of intelligence of most people, let's say the smart people in the world, there's very rarely, if ever, going to be one person that is better than five pretty smart people, just
Mhm.
like distributionally. And so this like genius that goes off and builds AI, that just doesn't make sense if you think about the distribution of intelligence. So that's at least how I've been thinking about it. Like 5/8 is greater than 1/12.
Yeah, I mean, it's good to have all of them. I'd rather have all 6, and I'd rather have that that 12 ranking person be somebody who's thinking outside the box and coming up with maybe that first prototype that then everybody else who's willing to come in and work on that and build it into something amazing with the guidance of that genius intellect. Um, that's how really awesome products get built. By the way, that's Matei Zaharia, um, creator of Spark, creator of MLflow. He built prototypes, worked on them with a team of people, collaborated, listened to people's feedback, came up with his own ideas, implemented stuff, and then handed it off when we have a full functioning team that can continue to maintain that, build additional features on it, change things when it no longer works. So having all of those people collaborate together is a recipe for success. That is greatness. It's the people at the right time is what you need as a foundation. And if you've never seen that, and that's what really brought this conversation to a head the other day. You sent me some code. We're not naming names, but you're like, this is the widely considered to be the finest engineer at this company that I'm interacting with right now. And then you pasted some code for me. And I looked at it and I'm like, yeah, it's pretty bad. Um, but I wasn't super surprised because the nature of that company, like what business they're in, and they're not in the software business. So they're not going to be like they're not going to be attracting top talent from anywhere that is involved with software. So to them and to people that are looking at it who have never worked with those top talent people or been in the room when that stuff was being built, to themselves, like to that peer group, none of them are wrong. If somebody's like, "This is amazing code," and you're going to have consensus from all of them. And you'll be like, "Yeah, this is really well done. Like,
Exactly.
look at how there's like comments on every line, and and look at like this clever thing that they did with the list comprehension. This is super cool." And you show that to somebody who's building legit software at a big tech company. They look at that and they're looking at other things. They're like, what's with the naming convention here? I don't even know what this function does by looking at the name. What's with all these acronyms here? Like, this makes no sense. I can't read this code. I have to now look at every implementation line to understand what is going on. And then you look at the length of it, and you're like, hang on, there's like 7 different things happening here that have nothing to do with one another. This is more like a public API that should be calling private APIs. But instead of that, it's just one function that has all the logic in it. So I can't test any of these things to verify what could go wrong. I can only test the output of this main function.
Yeah.
So when I need to debug this, I now have to come in and edit code to debug, which is the worst.
Yeah. You alluded to something that's really, really important, which is it's a culture thing. It's not that the guy is not smart. It's not that the guy or girl, or it could be a dog for this case. It's not that it's bad intentions or anything like that. It's the lack of the intern saying, I don't get it. Can you make this simpler? It's the lack of the manager saying, is that maintainable? It's the lack of this collaboration and sort of greatness culture that, as you alluded to, just isn't part of the business's core competency. And yeah, the code works the first time. Is it impossible to read? Is it impossible to extend? Is it error prone? Yes. But that's not a reflection of the person. It's a reflection of the culture. and because they're senior, they should probably have more stakes in influencing the culture. But if you've never been exposed to good code, I don't know.
I mean, it is that person's fault. They wrote it. They should know better for being a
Probably.
for having the job title that they do. They should know better because everything that was in that code sample has been written about ad nauseum in books about like
Fair.
first principle software development. Like, here's rules that have been learned over the last 50 years of writing code. It's somebody with hubris who legitimately believes that what they're producing is good, that they don't even need to get a peer review from it. They just wrote it, checked it in, and they're like, good to go. I'm a principal engineer, or whatever their job title is, something that doesn't equate to their capabilities. So it's a failing of, you're right, it's a failing of the organization in their hiring practices. Nobody screened the person that they brought in at that level, or when doing promotions, didn't screen that person's capabilities properly to say, is this person capable of operating at a level commensurate with their job title? And for these companies that are not tech related, but they're giving out large salaries to people that are technically not qualified to do what they're doing. And then they're wondering why they have to hire consultants to come and help them, because the people that they hired and gave these lofty job titles to don't really know what they're doing.
Yeah. Yeah. Yes. 100%. I was about to go into some more complaining, but I feel like we should keep
But
it anonymous.
but I mean, I've also interfaced with people at companies like that they're tech adjacent, or that they
Mhm.
like don't even like, tech is not their core competency at all. And you end up interacting with a team and you're like, man, everybody they're really good. Like, they're building maintainable stuff. They have the right way of thinking of it. And you're like, I would have involved in like data science or ML or in software engineering. I never would have thought to apply to a company like this, because what they do has nothing to do with tech.
Right.
But then there's this one person, usually like a CTO or a VP, who has took it upon themselves to enforce that culture at the company. And by the way, that's the job of a CTO. That's their whole reason for existence, is to make their technical organization more competent, more qualified, better at what they do, more like have a higher velocity. And unfortunately, a lot of CTOs get hired in those positions because they used to be an engineer somewhere and have some sort of street cred. And then some board was like, yeah, you seem competent. We'll make you the CTO. And you look at them, you're like, yeah, but the person doesn't know it. Like, they may know a lot about software engineering or computer science or data science or something, but they have no idea how to build a team or how to make a team get better over time. So they're not a leader. And unfortunately, that's what that role is for.
Right.
Inspire your team, make them better.
Mhm. All right. Let's conclude with an actionable tip for people to either learn about greatness or start implementing greatness at their own organizations. Do you have one?
Read books about about what it takes at those vaunted tech companies. Like, what did they learn over time? Many books have been written about this topic. Learn about what it was like. And some of the stuff you can read on people's personal blogs and stuff online. I've read stuff from like the early days of Yahoo. Now people kind of like, Yahoo, don't they do like news and stock market stuff? Yahoo back in 2004, that was the internet. Like,
Yeah.
that was your gateway to the internet. Uh, Somebody drank their milkshake by the name of Google, but during first,
Wait, was that a There Will Be Blood reference?
yes.
Hell yeah. That's my favorite
So
movie.
I drink your milkshake. Um, when you look at the first, 12 to 15 years of Yahoo, that's where the innovators were. They were building crazy stuff. They invented effectively the modern distributed computing stack. They came up with Hadoop, right?
Mhm.
Which opened the gates for all modern data usage and all modern application of machine learning and data science. Without that, it would not have proliferated like it has. And lots of geniuses work there, and they worked during that innovative period and did some amazing stuff. Once a competitor came along who was doing what they did better, faster, cheaper, more reliably, the brain trust left. We were like, once you start losing that core group of people who were the innovators, they all go to other places and innovate yet again because it's all about the people. It's not about the company or the tech. Uh, when that happens, yeah, the company just becomes nothing. You know,
Yeah.
it's sad, but it happens all the time in tech. So I would learn about those stories and what it was that they focused on, what was important to them at that time. Who did they want to be around? How were they thinking about building product? And what skills did they develop as a team? I wouldn't pay attention to the tech stack. It's irrelevant. It changes all the time anyway. And for a team I've seen teams go off the rails because they're like, our main focus for this year for continuing training is to become experts in Scala. It's like, yeah, cool. If you're writing in Scala, get better at it. Learn how to write more effective tests, learn how to do, an entire back end in that if that's your thing. Nobody cares. It's not going to teach you like fundamentally how to become a better organization. But if it's more like, what are our processes that we are doing? How do we approach product development? How do we approach improvements to things that already exist? And where are our skill gaps? Like, who do we not have, or what expert do we not have? How do we get that person? How do we build an environment where everybody is super pumped and excited to be working on this stuff, and identifying the places where it's like, yeah, everybody hates this thing or everybody's annoyed by this thing, because that's how to kill that culture, is all the great people leaving before the more junior people have absorbed enough of their knowledge and experience to become great themselves.
Got it. So sort of the one liner is give a shit and try.
And learn from the past, learn from others.
Hmm. Yeah.
There's
Yeah. Be
so
humble
many
about it.
postmortems out there about entire organizations and about tech teams. People have written online, YouTube videos of people talking about it. You can find a lot of information about what works and what doesn't work from a team perspective, or an engineering organization perspective. Give you insights into where should we be focusing our time.
Right. All right. My tip is simple. If you are looking to try stuff out, find people to try it out with. Typically, there's a few people on your team that are going to be more growth oriented, more interested in experimentation, more interested in learning. Find them and try it out. And then, if you have a small group that has a tried and true method, you can expand upon it. But trying to work in isolation is really tough.
It's a recipe for disaster. There's no worse echo chamber than the one inside your own head.
Yeah, exactly. And also for creating momentum to change culture, one person can rarely do that unless you're the manager. So,
Yeah. Yeah. I mean, I have seen inmates running the asylum work before. It's pretty rare. But if a whole group of people all like unanimously agree to directionally changing how things are done, you can convince management.
exactly. But one person almost never can unless they are the manager.
Right. Yep.
Cool. Couple more things. Timing of a company is important when you're trying to learn about greatness. It's arguably more important than the company name itself. And then also, greatness is implicit in the culture. There's rarely a like to do list. It's something that you sort of absorb by being there. There's a to do list to some degree though, but typically you can absorb a lot of the implicit ways of going about problem solving a lot faster and a lot more efficiently than reading it in a book.
Hmm.
All right. We're right at the hour mark. Perfect. Anything else, Ben?
No, this was fun. This is a good talk.
Yeah. Cool. Well, until next time, it's been Michael Burke and my co host.
Ben Wilson.
Have a good day, everyone.
We'll catch you next time.